So here is our notes from this past week on solving systems by graphing. I'll run through them pretty quick. A linear system, so line systems, so we're talking about two or more lines, consists of two or more linear equations. So down here we've got a linear system. This is in terms of y and x, and so is the other one in terms of y and x. And that's very important that your system has exactly the same two variables. And so if you have a system like this, what we're looking for is the solutions. And the solutions of the system are the x and y values that make both of these equations, I'm going to call them equations 1 and 2, make both these equations true at the same time. And the way we're going to use today to find the solutions is we're going to graph both equations and find where they intersect. So here's just a quick example. Now, I know these are lines because this is y to the first power, x to the first power. If either of these was squared or cubed or a square root, then they aren't linear. But these are just y's to the first and x's to the first. So linear equations, if you got yourself a linear equation, y equals mx plus b is the form you want. Remember, this form gives us our slope, and it also tells us the y-intercept. So let's go ahead and, or I'll go ahead here. I'll take that equation 1, and I'm just going to put them into this y equals mx plus b format. So I've got lined up here, and you can see what I want is my y alone on the left side, some number in front of an x, so a multiplication times x, and then some constant number with no x value at the very end. So the first thing I'll do is get this x term to the other side, and so I just have to add the 2x to both sides. So draw a little dotted line here as well. I know some of you like that. So I'll add 2x, move them over to the other side. Now I don't line him up with the 18. You can, as long as you recognize the fact that you can't add those two terms together. Instead, you just have to write them down as separate terms. And so we want to put the 2x first and then the 18. And the 18 is positive in this case because it doesn't have a negative sign in front of it. Okay. Then our last step here still doesn't quite fit slope-intercept form. It's got this number in front of the y, and I can't have anything other than a 1 right there. So we just divide by that lead coefficient, in this case a 6. There we go, divide by 6. Notice you have to divide everybody by 6, and you get y equals 1/3 x. 2 over 6 simplifies, and 18 over 6 is 3. And so then we can graph him very quickly. Y-intercept is 3, so I just go to my y-axis and put a point at 3. His slope is up 1 over 3, but I can't do up 1 over 3, but going up 1 to the right 3 is the same as going down 1 to the left 3. It'd be like a -1 over -3. But it puts my other point right there, and 2 points is enough to draw a line. So now I know that there's how my line lays, pretty close to, at least I know these 2 points are accurate, and these points are pretty close to what they're supposed to be. All right, let's do that to the other equation now. So here I am at equation 2. Let's do some green there. And this guy, I can see the equal signs right there. I just need to move that x over. Okay, and see, I've got them lined up here. I shouldn't really do that, but I know they aren't like terms. So I have a negative x term, and then I have a -1 on that side. And there I'm in slope-intercept form. Slope's kind of strange here. The slope there is just negative, and we have to have a 1 to represent a value. So it's -1 or -1 over 1. Okay, and more importantly, though, at the beginning, I need to mark that y-intercept. So y-intercept is at -1. And this line goes down 1, right 1, down 1, right 1. So right there. Or he can go up 1, back 1, up 1, back 1. So I'm going to put a bunch of those up 1, back 1s in. Because there's a key thing. Remember at the very beginning it says what we're looking for is where they share a solution in x, y. This x and y values that satisfy. That means just makes the equation true or lies on the line. And so we can see they share that point right there, and that's our solution to the system. Okay. and we give that as an ordered pair. So that's at -3. That's our x value, 1, 2, 3 over here at -3, and then it's up 1, 2 on the y-axis. So -3, 2 will be the location or the solution to that system. So here are our steps now to that, and I'm just going to write down exactly what we did. Now, first thing you do is write both equations in slope-intercept form. And then you graph them. Okay, so just to remind yourselves, that's y equals mx plus b form that you're going for. Find the coordinates then of the intersection where those lines cross. Our last example, that was -3, 2. Check your solution. Now, we did not do that step, so we're going to do it here in just a moment. Check your solution by substituting the coordinates back into the, and I'm going to put original equations. Let's go ahead and do this step right now, and I'm going to do it right off to the side here. Okay, so here's my first equation, 6y minus 2x equals 18. And here's our solution we think we have. We said the solution's at -3, 2. So all you're going to do is substitute in -3 for the x and 2 for the y and see if it makes the equation true or false. Okay, so I'm going to plug in a 2 for my y. I'll plug in a -3 for my x. And the question is, does it equal this 18 on the right side? So I'm not really going to do math on the right, just going to figure out what the left side equals. That's 12. Negative times negative is positive, so that's a +6. Yeah, 18 equals 18. That checks. It's true. It is said to then satisfy that equation. Okay, then I'll just check it in the other equation because it has to make them both true. So my other equation, this y plus x equals -1. Let's see, my y is a 2, my x is a -3. Does that give me -1? Yes, it does, and that is a check then. Both of them are satisfied by that solution, and so it's a solution to the system. And then write your solution as an ordered pair. Okay, so that's it. I'm just going to run through our examples here really quickly. Leave the homework up to you. Let's see here, equation 1. Or example 2 here, we'll put this thing in slope-intercept form. I'll try to do this now. I'm just looking at it and saying, hey, I want to keep this one where it's at, so I got to move the 4x to the other side. So that's what I'm doing, subtracting that 4x. And all that does is give me 3y equals -4x minus 3 divided by 3. It's this little two-step process every time. And then you do want to simplify. -4/3 doesn't simplify, but -3/3 is -1. So there's our first equation. So let's attack this second equation up at x plus 3y equals 6. I'll divide by, I'm supposed to graph that black one first. Let me graph the black one here. Y-intercept is -1 and then down 4/3. So here's my down 4 and over 3 right there. Sorry if there was a skip in the video. Then up 4 and back 3. Just splice it together. So there's my first line. All right, second equation now. Got him written down here. This one's going to be a little bit easier because I'm just moving this single x. I don't have to think about a number in front of it. Just -x plus 6 there. Slide that over just a little bit. And then I divide by 3. Here we go. So y equals, and there's a 1 right in front of that x. We just don't show them. And I get +2. There we go. So his y-intercept is at 2. And then he goes down 1 and over 3 right there. But he also goes up 1 and back 3. And there we go. There's the overlap. There's the intersection. And so there's our solution at -3, our x value, and our y value is +3. I'm going to run over here really quickly. I'm going to just show you that check again. So I'm checking -3 and 3. So here's my first equation. times y. My y is a positive 3. Here we go. Does that equal negative 3 is the question. Negative 12 plus 9, negative 3. Yep, that checks. And then in the second equation, negative 3 plus 3 times 3, does it equal 6? Negative 3 plus 9, 6 equals 6. Yeah, check. So there's that check, and I know that is the correct answer for sure. Alrighty. Example 3 here again. I'm going to pause the video. You can try it on your own. So there's my two equations now in slope-intercept form. So I'll graph this purple one here. Just freeze the video if you need to see the work for that. So there is a positive 2, and then I go down 3. So I'm going down 1, 2, 3, and then all the way over here to 7. Don't count those. We just know this is 6, 7. So there's down 1, 2, 3 over 7. I put a dot right there. Okay, and I maybe put another one in. Those dots are far apart. I'm going up 3 and back 7. So that puts me, oops, going to go up one more. There we go. And now I can see that's where my line sits. And now I'll do the green one, looking for that solution they share. So his y-intercept is negative 6. His slope is up 5. So 1, 2, 3, 4, 5. But I don't have to count right 7. I can just see 7 lines up right there. So there's up 5 and over 7. And lo and behold, yeah, they got a nice point of intersection we can read. His coordinates are right there, the point they share, 7, negative 1. I'll leave a check up to you. So on page 2, we just have more examples of the same thing. I'll do the first one because it kind of has a little surprise for us. Then I'll leave these others to you, the second two, and I'll show you the answers. So here we go. Y equals 2 is kind of an unusual equation. We're used to seeing our equations as y equals mx plus b. This is just y equals, well, there's no x, so it has really no slope, but it does have a y-intercept of 2. And so it's going to cross just right there at 2. But it's still a line with no slope, so it really rises 0 and runs 0. Um, or rises 0 and runs 1, because 0 over 1 is still 0, or rises 0 and runs 2, 0 over 2. So this x can really be anything it wants to be, 1, 2, 3, 4, 5. It gets multiplied by 0 and always spits out a 2. This is actually our constant function we saw earlier in this chapter. We said, hey, we don't use him very often. But there he is. He's just, hey, where does y always equal 2 at? The other equation, we just have to move this 4x over. So we're just subtracting that 4x. So y equals negative 4x minus 2, y-intercept of negative 2. The slope means down 4 over 1. Okay, that's still equal to negative 4. But again, I can't go down 4 because I run out of room. I've seen this before. And so what I do is I kind of think of it as a positive 4 over negative 1. That means it's still equal to negative 4. 4 divided by negative 1, but now I can go up 4, back 1. 1, 2, 3, 4, back 1. And so there's the point they share, and that is my solution at negative 1, positive 2, negative 1, 2. No surprise, my y value is 2. This is the only y value that satisfies that first equation. I'm going to pause the video, you try the other two, and then check your answers. So there's problem number 5, an answer of 3, negative 2. There's x is 3, y is negative 2 where they intersect, and for number 6 over here at negative 2 and positive 4. All right, number 7 here, and parts A and B. This is like that step 3 in our solving of these systems where we check our solutions. Is 4, 1 a solution to the entire system? So you have to check that 4, 1 in both equations. So I'll just type in the 1 there, equals 3 times 4 minus 11. And so here I'm just checking the right-hand side. Does it give me a 1? Oops, minus 11. A couple of undos. There we go, minus 11. Did the same thing again. Yeah, that equals 1. So this is going to check. Let's check the bottom equation in this system. So when x is 1, the y is a 4. Does that make it true? Negative 3 equals negative 1. That is not true. So no. 4, 1 is not a solution. Question B will do the same thing. First equation just says x is always 4, so our, our line here always runs to 4 and then some y value. It doesn't matter what the y is because it just says x is always 4. So y could be 1,000,000, y could be 7, or y could be 1. So certainly 4, 1 is on this line. If you think about its graph real quick, 1, 2, 3, 4, there it is. There's x is always 4, and it certainly goes through 4, 1, which would be somewhere in that purple dot. Okay, so it's just really a question of does the second one also go through 4, 1? So I'm going to put a 1 in for the y, I'll put a 4 in for the x, and I'll see if the left side equals the right side. Yeah, left side is 2, right side is 4 minus 2 is 2. It checks, yes. 4, 1 is a solution of the system. Okay, and number 7, part A, the 4, 1 was a solution to the first equation, but not the system because it didn't satisfy the second one at the same time. All right, now we're going to get out our graphing calculators for this next part. So I'll pause here and pull up my graphing calculator. So here I've graphed the first two equations. Be careful, I'm going to hit my home button here so you can see how it originally graphed. It graphed like that, and then you may have to zoom in, zoom out in order to see what exactly is going on. So here I'm zooming out, getting further away, and I can see my other graph now, and so I can see where they share that solution at negative 94, 82, and that's all I have to do is write that guy down. I found my answer. Okay, so I'll pause the video and you can try the other three. Really look at them, see if you can come up with the correct solution. Don't get tricked. It should be as easy as this looks, but you have to be wise when you do it. So here is equations from equation 8b there. And when you first graph it, you only see one solution or one graph. You may want to zoom out and zoom in and look around. But ultimately, if I hide my purple one, you can see the green ones right below it. There's the purple one. So they're exactly the same equations. So where do they intersect each other? The answer is they intersect each other everywhere. And so we're going to add that. We'll just say infinite solutions right here. Now you do have to be a little bit careful. This is kind of being taking some liberties when we just answer it infinite solutions. Yes, it does have infinite ones, but they're the only solutions are the ones that show up on this line. Okay, which line, the purple one or the green one, doesn't matter because they're on both of them. So 3 zeros on this one, and if I put the purple one up and hide the green, I can see 3 zeros on the purple one. So they share all exactly the same points. And so we do want to say, hey, it's, yeah, infinite solutions, but it's better form to say that it's on one of these lines. But people don't know which line they should choose. And the answer is, well, you should really just take one of the equations. I'm going to take equation 1. I'm going to move the 4x over by subtracting it. I'm going to divide out this lead negative. And when I do that, it just flips everybody's sign. Okay, so that's just dividing by negative 1 there. Flips all their signs. And so that's what both equations actually are. If I just divide this one by 2, you can see I get 2 divided by 2 is just y. 24, negative 24 divided by 2 is the negative 12, and 8 divided by 2 is the 4. So they're the same equations. So it's really infinite solutions that lay on this line. And now I'm going to go ahead and pull up C, if you've graphed that one. Here's my C, and here's my other equation. And this one, boy, you have to be careful there. For some people, they had if they weren't zoomed right, they looked at it and said, hey, those are the same lines again. You see, I can zoom way out and make it look that way. But if I zoom back in, I can really see, no, they're not the same line. They're just parallel to each other, and so they never intersect, and so we answer no solutions. These two lines have the same slope. Same slope. Parallel lines, your parallel lines. And then lastly, D here. I don't think 8D had any surprises for us. graph that guy here real quick. Can't find him right away. We're going to pull back on him. There he is, over to the right. We'll click that point, and I get negative, no, positive 91, comma negative 35. There we go. And we'll just wrap this thing up and then leave the assignment for you guys to try. So wrapping up our last two little lines here, don't forget, so when you're solving these things, if the lines are parallel, then there is no solutions. And if lines are the same, then there are infinite solutions. So down here at the bottom is just any notes you wanted to add about what you can remember about our lesson here. Some of the things I remember is like solve systems by graphing. That's kind of our main thing here. Solve system by graphing. And the key things were graph each line or each equation, because this is extendable to other types of systems. They don't have to just be linear. Graph each equation, find point of intersection. Where they share those solutions. All right, that's it. I will have all the solutions to the answer sheet attached, or to the homework at the end. Real quick though, because we did not assign homework to everything, we assigned all the problems. We did 1 through 13 odd, and then number 4 at the very end on the last page. If you do those, you'll be in great shape.